Your feet would die before your head does. Not metaphorically, physically, stretched apart, atom by atom, long before you ever reached the center. This isn't science fiction. It's what Einstein's equations predict, and what the Event Horizon Telescope actually photographed in 2019. But here's the question that keeps physicists up at night. Once you cross the point of no return, what happens next has never been confirmed by anyone. Because nothing that crosses it ever comes back to tell us. Every black hole has an edge. Scientists call it the event horizon, the line where gravity gets so strong that not even light can climb back out. Cross it, and you're not falling the way you'd fall off a chair. You're falling out of the reachable universe. Here's where it gets strange. Someone watching from a safe distance wouldn't see you cross it. Not really. They'd watch you slow down and down and down, your image redder, dimmer, frozen at the edge forever. That's time dilation, a real, measured effect of relativity, not a visual trick. But you wouldn't feel any of that. Inside your own falling body, there's no freezing, no slow motion. For a big enough black hole, you'd cross the horizon smoothly, feeling completely, eerily normal. That calm doesn't last. Keep falling, and gravity starts pulling harder on your feet than on your head. The closer you get to the center, the bigger that gap grows. Physicists call it tidal force. Push it to the extreme, and it earns a name that sounds almost like a joke: spaghettification. For a small, stellar mass black hole, this happens brutally fast, stretched and torn apart within microseconds of crossing the horizon. But the giants are different. The supermassive black holes at the centers of galaxies, the one the Event Horizon Telescope actually photographed in M87, or Sagittarius A star, at the heart of our own Milky Way, have horizons so large that the pull there is gentle. You could cross in and survive. For a while. The stretching would still catch up eventually. It would just take longer. So what's actually waiting at the center? General relativity gives an answer: a singularity, a point of infinite density where the math itself breaks down. But here's the honest part. Nobody has ever confirmed that. No observation has ever reached inside an event horizon, and many physicists think quantum gravity, a theory we still don't fully have, rewrites the ending completely. Here's what we do know for certain. In 2015, LIGO detected gravitational waves rippling out from two black holes colliding. Direct proof these objects are real and that they warp space-time exactly the way Einstein predicted. Everything up to the horizon has now been tested and confirmed. What's past it? That's still one of the last true unknowns in physics. And that gap between what's confirmed and what's still theory is exactly where our next story lives. A discovery from the James Webb Space Telescope that even NASA's own scientists have called unsettling.